Trig, section 2.3, finding trig function values using a calculator. Now you should be using this. Got listed in the syllabus where if you don't have this, you can get a 30-day trial version on the TI website in order to get one that you can use. Hopefully you've got one that you can use here. And hopefully you can see the screen that lights up here. We'll do our best to show you the buttons to push. How do you use a calculator for approximating the values? Why do they say approximating? Because almost always it's going to be a decimal approximation is what's actually the value. So first of all, let's do the sine of 45 degrees and 12 minutes. How do you find that? Well, pretty straightforward. Press the sine button. It gives you the parenthesis already for beginning. I didn't put that in there, but I guess the calculator will, so you've got to finish that also. Put in a 45, a second, and then angle, which is above the apse. The degree mark is number 1. 12, and then the minutes go second angle, which is above the apse. That's number 2. If you need seconds, use the green alpha double quote here next to the memory, the plus sign. But we don't need that. So we also have to close our parentheses. Now, when I say have to, you probably don't have to. It will close them because it's the end of the statement, but you should close those. Another thing you need to make sure of, check your mode. You need to be in degree mode. The mode button here is right next to the second. Second quit is going to be used a lot, but mode is without the second. And to make sure this says degree mode. There's radian, there's degree. By default, all these first ones are down the left-hand side, but degree mode is not a default on the TI-84. If you've done that, you can do second quit and get out of there. You'll be back to this line. It won't have messed anything up. You won't have lost anything. And even though you're at the beginning of that line, you can press enter, and it will give you the approximation 0.7095707365. It gives you way too much. And you're going to have to try to figure out, we'll talk about this later, how many places you need for that. But it's that easy. Now that's good for the sine, the cosine, and the tangent. Suppose you want one of the other three. We're going to look at perhaps another way of doing this, but we're going to use some trig identities for this. If I want the secant of 97, and I'm going to use now decimal degrees, 0.977 degrees. Now what's nice, if you're in degree mode, you don't need the degree mark. It's only when you need degrees and minutes and maybe seconds that you would need that degree mark. If you're in degree mode, you can leave that mark essentially off of there. It won't hurt if you do or don't. But the secant is really 1 over the cosine of that 97.977. So that's how I'm going to put it in. You can clear out the screen, start with the first screen. 1 divided by cosine, it puts the parenthesis in, 97.977. Like I said, you can leave that degree off there if that's all you got are decimal degrees. When you press enter, this gives you a negative 7.205879213. Okay. So, what happens if you want the cotangent? Well, let's see, if I want the cotangent of 51 degrees, 42 minutes, and 15 seconds, I need 1 over the tangent of 51 degrees, 42 minutes, and 15 seconds. Clear this out so we can start fresh. 1 divided by tangent. 51 second apse, go to the angle 1. 42 second apse, go to number 2 for the minute. 15 alpha plus, to go to the double quote, parenthesis, enter. 0.7896343397. Okay. Now, that's not so bad. It's pretty easy. If you want to find an angle measure using a calculator, this is finding the value of a trig function given an angle. Suppose we want to find an angle measure using a calculator. So we did this for one of those last problems in the last section, section 2.2. Suppose we want theta to be in the interval from 0 degrees to 360 degrees. Remember, this means is an element of, looks like a C with a line. Square bracket means include the endpoint. Parenthesis means exclude that endpoint. So it's from 0 to 360, but don't go all the way to 360. Suppose you're given the sine of theta is equal to 0.9677091705. How do you find theta? Well, you might have noticed above these trig function keys is a sine with a -1 exponent. That is not 1 over sine. That is not the cosecant. That is the inverse sine function. It's just short notation for it. Theta is the inverse sine of 0.9677091705. Now, would this give you theta? No, this will give you at least a reference angle you might have to figure out. So, if you want all the values, then you've got to say, okay, which of these quadrants is the sine positive? Well, they're all positive in the first quadrant, and the sine and cosecant are positive in the second quadrant. So this will give you something to help you find both of those. Let's see here. If we put that in, inverse sine is second sine. You don't need the 0, you just need the 0.9677091705, and then close the parenthesis. When you press enter, it gives you a degree measure because you're in degree mode, and it gives you 75.4 degrees. Now, if you think about that, that is this angle right here. That's the first quadrant. How do I find the angle in the second quadrant? Well, I need 180 minus. That's 75.4 degrees. You can do that on your calculator without doing much work. 180 minus. Every time you calculate something, your answer is placed in a variable called ANS. It's above this negation key in a different color. Mine's blue. So it's the second color. Mine's blue. So 180 minus that answer of 75.4, and this is 104.6 degrees. This one, makes sense, is in the second quadrant. Bigger than 90, less than 180. So you can find all those values. If we do a cotangent, let me change colors. The cotangent of an angle, we don't know what it is 1.0545 So, in what quadrants is the cotangent positive? All in the first quadrant. The cotangent is also positive in the third quadrant. So first quadrant, third quadrant, but let's see what this gives us. Now you can't do inverse cotangent because there's no cotangent even on the keyboard here. So what you need to do is first write this with a tangent. 1 over the tangent of theta is equal to 1.0545829. Now, you can think of that decimal over 1, and instead of 1 over tangent, you can do tangent over 1, or just the tangent, but that'll give you 1 over 1.0545829. Well, I'm running out of room here. Now you can use the inverse. Theta prime may only be a reference angle, is the inverse tangent, or tangent negative 1, of 1 divided by 1.0545829. Let's see what that gives us. Let's clear this off. So I need inverse tangent, 1 divided by 1.0545829. This will give me an angle, 43.47. That's the one in this first quadrant. I'm going to put that over here. 43.47 degrees. Now, how do I find the one in the third quadrant? I don't subtract it this time. I add it to 180. So I just need to say plus 180. And I get 223. We'll go 2 places. I should have been 48, I guess, degrees. Those would be those two. So drawing a picture helps you think this through, how to find those, and really only worry about this being a reference angle. These numbers, the 43.48, the 75.4. It could turn out negative. That would be in the fourth quadrant if they measured it this way. We'll learn more about that later. Just assume that it's going to be the same angle that you would use in the first quadrant, only positive. So it's still the reference angle, make it positive. Okay, let's do some examples. These should be found on page 63. That's too light, isn't it? Number 22, we'll start with. Now, 22 says, use a calculator to find the decimal approximation for each value. Give as many digits as your calculator displays. Simplify the expression before using the calculator. What do they mean by that? Let's see. 1 over the tangent of 90 degrees minus 22 degrees. Well, let me put the calculator aside for a second. So, this can be done several ways. You can put this in as it is, and we're going to do that. But you can also write this as 1 over the cotangent of 22 degrees. Why? Because this is the cofunction identity, 90 minus theta, 90 minus a. But 1 over the cotangent is also a reciprocal identity, which is the tangent of 22 degrees. So let us do that both ways. We'll first put this in, because it's the easiest, I guess. The tangent of 22 degrees. Don't even need the decimal or degree mark. We get 0.4040262258. Now let's try it this way at the top. 1 divided by the tangent. Then we're going to put in 90 minus 22 and calculate that. Get the same thing. 0.4040262258. So So your calculator can do a lot of those calculations for you, make it a little easier. How about number 34? So for number 34, find the value of theta. Theta is in the interval from 0 to 90 inclusive. They've got square brackets on both here. It satisfies each statement. Write the answer in decimal degrees to 6 decimal places. So on 34, they say the cotangent of theta is 0.21563 481. Well, I'm going to go have to change this. 1 over the tangent is this 0.21563 over 1. So the tangent of theta is 1 over 0.21563 and theta is the inverse tangent of 1 over 0.21563 Let's see what that is when we put that in. Clear this out. Second tangent to get inverse tangent. Then 1 divided by, don't need the 0, just the 0.21563 481. Did I get the 4? Yeah, 481. 21563 Close the parentheses. We get 77.6 places. 831359 degrees. Hold it. Is that in the right place? From 0 to 90, that should work. We just wanted the first quadrant, and 77 is someplace here. Okay. What about number 44? Instructions. Use the calculator to evaluate. Okay. With calculator. That's that thing right there. Okay, we want, see, for 44, the sine, 28 degrees, 14 minutes, times the cosine, 61 degrees, 46 minutes. Need some room here, plus the cosine of 28 degrees, 14 minutes, times the sine of 61 degrees, 46 minutes. Okay, evaluate this thing with a calculator. Now, it's important here, I guess, to get those 4 steps. You evaluate this with a calculator. That's a step. You can write it down. That's your problem. That's a step. You need a couple more steps, so we can't just take the answer. Finally, let's do these a little bit at a time. Let's clear this out. Okay, the sine of 28 degrees. Now we need the degree. Second apps. 14 minutes. That's second apps, number 2. What is that value? This is 0.47306 times. Now, let me also mention a couple things. You don't need to do this if you're interested. There's a stow button right above the on button that stores values. Once you've calculated a value, you can store it. I'm going to stow this, answer, little arrow, and I'm going to put it in A. I need to say alpha A. Okay, so I'm going to use A for that. Let's find the cosine of 6146. Cosine of 61, second apps 1. 46, second apps 2, enter. This is 0.47306. Well, who cares? That I'm going to store in B. So stow alpha B takes that answer. Those are two the same. How about that? Wonder what that means. Plus the cosine of 28 degrees, second apps 1, 14 minutes, second apps 2. That's the 0.88102, etc., etc. I'm going to stow that in C, alpha C. And I need the sine of 61 degrees, second apps 1, 46 minutes, second apps 2, 6146 sine, press enter. It's the same thing. 88102, etc., etc. That's C. Put this in D. Stow alpha D. It's down here next to matrix. Enter. Now you could go back and say, well, heck, that's just 2 of these plus 2 of those. Or, not 2. We'd have to multiply them together. That's those squared. We can take, now, all of these are variables that have those values stored. So what is A times B plus C times D? Well, it's alpha A times B, alpha B, plus alpha C times alpha D. 1. Hold it. Could we have done that easier? Well, yes. If you notice, you've got the same values here because these are cofunctions and these angles are complements. So the cosine of 6146 is the same as the sine of whatever makes that go to 90, which I bet is 2814. So this is sine squared. And the cosine, the sine of 6146 is the same as the cosine of its complement, which I'm pretty sure is 2814. So this is sine squared, this is cosine squared. We have an identity that says, I don't care what angle you put in, just so they're both the same. You get 1. My gosh, we could have done that in our heads. Shoot. But we used our calculator because we needed 4 steps. Okay, number 52. See, number 52. Decide whether each statement is true or false. When we're given 2 cosine, 38 degrees, 22 minutes, equals the cosine of 76 degrees and 44 minutes. Well, that's got to be true, right? Because 2 times 38 is 76, and 2 times 22 is 44. No, they're trying to show you, with parentheses especially, I guess, you cannot distribute inside this trig function. That trig function has to be applied first, and then you can multiply by 2. But let's confirm that by looking at, clear this stuff off, 2 times the cosine of 38 degrees, second apps 1, 22 minutes, second apps 2, press enter, 1.568109, and the cosine of 76, second apps 1, 44, second apps 2. When you press enter, you get 0.22948. These are certainly not equal. Therefore, it must be false. And because looks like we've only got 3, maybe just 2 steps here, we've got 3 out of count of 3. The coefficient 2 does not distribute. 2 cosine 38 degrees 22 minutes. No. Now you got 4 steps. Okay, last problem, 64. Now, this problem uses a formula within the text. So if you get to a problem and you say, I don't have an idea what they're talking about, look at the examples in the text, which you should have been reading anyway. They've got a formula. The force equals W sine theta. Well, this is really the force for the grade of a hill, the force coming down the hill for some car. And you could be driving down the hill, you could be driving up the hill, it all depends. We'd have to overcome something one way or the other with a brake if you want to stop. So their question on 64, cars traveling on a -3 degree downhill. So this is 3 degrees here, -3 downhill. We're going to right, left to left here. The grade resistance of -145 pounds. So F is a -145 pounds. That's what that is, the grade resistance. Trying to pull you back. Determine the weight of the car. That's what W is, the weight of the car. So we just have to plug this in. The picture is worth some steps here. 145, W, we don't know, the sine of a -3 degrees. Now let's see what happens with that. Well, let's divide first. -145 over the sine of a -3 degrees equals W. So let's clear this out. Negative, you would use the negation, not subtraction. 145 divided by the sine of a -3, and I got degree mode, so I'm good. And you get 2,770.56 pounds. That's the weight of the car. Sort of makes sense. So we're going to have some problems that'll be nice because you can use some sort of nasty numbers. Don't have to worry about everything coming out nice. But then you get to use your calculator. You should be able to do section 2.3 problems at the end of chapter.